go. A blank is a mathematical relation that maps a set of input values to a set of output values. So what is that blank? A what? Starts with an F. A function. All right, it's a function. And so that each input value is mapped to exactly how many output values? One. All right. For instance, I have a juicer at home. If I take an orange and I put it in the juicer, what do I get?
Orange juice.
Orange juice. I take an orange, I put it into a juicer, what do I get?
Apple juice.
I get orange juice again, don't I?
Yeah.
If I put in an orange and I get orange juice and apple juice, is that correct? No, that would not be a function because every input should have how many outputs? One, a singular output. All right, that is a function. So last year and years before that, you would check it by a vertical line test. And Kate Gonzalez would call it a VLT, which I find hilarious. All right, but a vertical line test is not going to be the definition we use for a function. Okay, not this year. Okay, because later on we're going to get to what's called a polar function. And a polar function doesn't actually pass the vertical line test. And so we're going to use the definition of each input has exactly how many outputs? One output. All right, so here we go. And so a set of input values is called what's our input values? Usually we call them our X's most often, but there are inputs. It's called something that starts with a D. Domain. It's our domain. And it represents the independent variables. All right. And the set of output values is called the what? It's not the domain, it's the what? It's the range. And that represents the dependent. The dependents change because of what's input. It's what's independent variables are put in there. All right. And so here we go. A function is positive when it lies above the x-axis. Makes sense. It has a positive y value. All right. And a function is negative when it lies what? Below. Okay. Hopefully that makes sense a little bit. Now, I'm not going to get into it too much, but we will have multiple representations. They modeled AP pre-calculus after some things in AP calculus. And so in AP calculus, we've done these a lot. We've done graphical, analytical. Sometimes I call it algebraically or analytically. Numerical, which represents with tables, and verbal. Okay, so a lot of times we'll be using all four of those representations in this class as well. All right, I got my first reader of the year. Who's got me?
I got you.
Go, Robbie. Let's do it.
The figure shows an empty vase. At time t equals 0, water begins pouring into the vase at a constant rate until it is full. Which of the following could depict this situation where time in seconds is independent variable?
Love it.
And the height of the water in the vase in inches is a dependent variable.
Love it. All right. So I'm pouring water into my vase at a constant rate. Is it filling up my height at a constant rate?
Yes.
No. Now, if it were a cylinder, let's say this thing were a cylinder and I was filling it up with water, then would it be filling up at a constant rate? Yes, the height would be going at a constant rate because it's not going out or in depending on how this is going. Look at our vase here. When we're getting our vase right here, is it going slower up my vase or going faster up my vase? It's going up, yes? My height is going up. It's an increasing height, true? Mm-hmm. However, is the rate of my height increasing or decreasing right here? It's decreasing. Why? Why is it decreasing right here? Because my width is wider here. However, once it gets to this line about right there, then what's happening as we fill up our vase? It's going up faster. It's increasing. All right? And so my rate would be increasing once I hit that level. All right? And so let's break it down. Is it A? Is the height going up constant? Is it going up as a constant rate? No. Now, if it were a cylinder, would that be the case? Mm-hmm. For sure. All right, but it's not a cylinder. It's that right there. All right, let's look at this one. What's happening here? It's what? It's increasing. It's actually getting faster here. The rate is increasing. Is it not? You see how it's filling up quick right there? And then it levels off? Is that what it's doing? No. It's kind of doing the opposite. This one, dear goodness, they actually lost water right there. Like there's a hole in your vase. All right? That's not the one. All right? However, looky here. It's filling up, but it's actually going at a what? The rate is decreasing. It's going up still. All right? However, then it starts doing what? The rate is increasing. So this one actually aligns with what? D. All right? The one that we're working on. All right? So let's talk about our graphical behaviors. All right? So the first word that we're going to be dealing with is increasing. So increasing, in America, which way do we read? Left to right. And so an increasing function is going which way? Okay, yes, we're going left to right no matter what. But an increasing function is going which way? Up. All right, so an increasing function is going up. And mathematically, this is how we say it. If A is less than B, okay, so if I'm going this way for A to B, then my value of B is going to be greater than my value of A. All right, which means it goes up. All right, a decreasing function means what? The function is going down. All right, the function is going down. Now, these are two new words to you probably. Concave up and concave down. All right, so everybody has hands in this class, yes? Can we see them? Do this, all right? I am not a Miami Hurricane fan. However, I'm not going to say this U. Just do this. You're right there, all right? So everybody sees their U. That's concave up. You see it? Okay. So no matter if it's a decreasing function, do you see how this is going down? Do you see how it's going down from left to right? Okay. And this is an increasing part of my function. This is still concave up. All right. Flip it over. There's concave down. All right. The AP exam person will not cut your hand off, so you can use this the entire class. All right. And so now if it looks like that, it's concave down. And what that means is the rate of change is increasing. The rate of change being positive is an increasing function. But if the rate of change is increasing, that's called what? Concave up. If the rate of change is decreasing, that means it's what? Concave down. All right, let's play. That means, so let's look at example 2 now. All right, and I need another good reader. All right, Cohen's going to be my reader. Here we go.
The figure shows the graph of the piecewise function f over the interval 0 less than or equal to x less than or equal to 9. What are all the intervals where the graph of f is increasing?
All right, fantastic. So when is f increasing? What does that mean for f to be increasing? The function goes up. All right, and so when does the function go up? Okay, we cannot call it -2 to 4. All right, because -2 to 4 is our output values. All right, now, for instance, look at this with me. If you say y equals 2 as part of your answer, how many times is y equal to 2? Right here, right there, right there. How many times? 3. And so we can't describe it with our y values. We have to describe in terms of our x values. So our x values are going to be our answer describing what the y values are doing. Does everybody catch that? All right. And so when is f increasing? From here to there. So how do we say that? It's from 0 to 3. 0 to 3. My function is increasing. Where else is this function increasing? 7 to 9. All right. And another way that you might see it written is 0 is less than x, which is less than 3, and 7 is less than x, which is less than 9. This is what you call an open interval. Okay. We won't do it necessarily. However, this is a closed interval. That means 0 is less than or equal to x, which is less than or equal to 3. Okay, that's actually a closed interval. But that's not our answer. It would be right here. All right, Cohen, pick somebody.
Josh, go ahead.
The second thing that needs to be clarified in this phrase rate of change. This phrase will be utilized repeatedly throughout this course, so it is important that we understand its meaning. Essentially, rate of change simply means slope. Anytime we see the phrase rate of change in this course, we can generally replace it with the word slope to help us better comprehend what is being said. We must read very carefully in this course, stating that f, or function, is increasing is very different than stating that rate of change of f is increasing.
All right, love it. All right, so our reading is extremely important here, and so we have to kind of know our terminology, okay? So I covered it up. I don't really want you looking at the answers, but let's play. All right, so is F positive or negative on this first one? Is F positive or negative? Caroline, was F positive or negative on that one? Positive. Positive. Why is it positive? Because it's above the x-axis. My y values are positive. Love it. All right. And is F increasing or decreasing, Campbell? Decreasing. Tell me why. It's going down. All right. It's yellow and timber. All right. And what is the rate of change of F? What is the rate of change of F? Is the rate of change of F increasing or decreasing? Is the rate of change of F increasing or decreasing? It's increasing. Why is the rate of change of F increasing? Because what's its concavity? Because it's concave up. Okay? All right, let's do it again. So now we're going to work with this graph. All right? And so the graph of G, is the graph of G positive or negative, Allison? G's negative. Why is G negative? Because the y values are negative. It's below the x-axis. Love it. All right. And is G increasing or decreasing, Kefa? G is increasing. Tell me why. Because it's going up. Love it. All right. And then the rate of change. What is the rate of change of F, or G in this case? Is it increasing or decreasing? Is what? Decreasing. Why? Because it's concave down. All right. All right. Pretty simple. All right. Let's keep. Here we go. We got lots of examples. All right. Who read that last one? Josh, pick somebody.
Noah.
The graph of h of t and its dashed midline for two full cycles is shown. 5 points F, G, J, K, and P are labeled on the graph. No scale is indicated and no axes are present. The t coordinate of F is t1 and the t coordinate of G is t2.
All right. Love it. And so then it says on the intervals T1 to T2, which of the following is true about H? So we need to know that T1 is actually what? It tells me in the reading. Is F. So I'm going from F, and then I'm going to what? G. And so let's talk about it. So let's look at our answer. So H is positive or negative. So is H positive or negative from F to G? Positive. Why is F positive or H positive? No. Has nothing to do with concavity right now.
It's going from -6 to -3.
No. We're actually looking at what values for positive? The y values. So when we look at our y values, we have 4 and 3. Do you see how it's above the x-axis? Okay, so that's why H is positive. All right, and so then it's asking if it's increasing or decreasing. And so what's it doing there? It's decreasing because why? It's going down. All right, and so that's why this one lines up with B. All right. And so now let's do number 2. Describe how the rate of change is changing. So the rate of change of G, dear goodness. The rate of change of H, is it increasing or decreasing from F to G? It's all right. So if I'm talking about the rate of change increasing or decreasing, I'm talking about its what? Concavity. All right. And so is it concave up or concave down? It's concave down. So the rate of change of H is what? Decreasing. Because why? Concave down. All right. Going from what? K to P. All right, so I'm going from K and then I'm going to P. So, is our function positive or negative from K to P? It's negative. Why is it negative, Cohen? The y values are negative. I got -4 and -1 going on, so it's below my x-axis. So we're negative. So it's definitely not A or B. And then, is it increasing or decreasing from K to P? It's increasing. All right, and so it's going up there, and so that's why it is increasing. Now let's talk about the rate of change. And so the rate of change is what? Increasing or decreasing from K to P? It's decreasing. Because why? Because it's concave down. All right, so now we have our figure from 0 to 9. We need to figure out which of the following intervals is K negative and decreasing. Well, what does it mean to be negative? What? Negative y values. And then decreasing means which way? It's going what? Down. So when is it negative and down? Going down. D to E. All right, pretty simple. All right, let's keep moving. All right, so let's look at number 6 now. It says things about my rate of change. So let's break it down little by little. So the rate of change of K is negative. What does that mean? What does the rate of change being negative mean? Okay. What does rate of change decreasing mean? That means concave down. Now I'm saying rate of change is what? Negative. So what does it mean for rate of change to be negative? That just means going down. Okay, that's basically saying, hey, it's a decreasing function. So this says, when is it going down? So is it going down from A to B? No. So let's look here. The rate of change of K is negative on the interval B to C. So again, rate of change being negative means what? It's going down. Is it going down from B to C? No. So the rate of change of K is positive from D to E. Is that true? No. So now here we go. The rate of change of K is positive. So what does that mean again? It's going up. And so is it going up from E to F? Yes. All right. All right, let's look at number 7. All right, I need a good reader. Lucas, you got me on this one.
Okay. Which of the following statements about the rate of change of K is true?
Keep going.
The rate of change of K is decreasing on the interval from A to B.
All right, what does that mean? The rate of change is decreasing. That means what?
Concave down.
That means concave down. Is it concave down from A to B? No. All right, let's keep going on B then.
The rate of change of K is increasing on the interval from B to C.
What does that mean? Means it's what? No. The rate of change is increasing. That means what? Concave up. So is it concave up on B to C? No. So let's go to C now. The rate of change is increasing. What does that mean? Concave up. So is it concave up from D to E? Yes. All right. All right, let's look at number 8 now. All right. So on number 8 it says, which of the following intervals is what? K increasing. So what does that mean? It's going up. And then it says the graph of K is concave down. So where is it going up and concave down? From B to C. All right. And so it's going up and concave down from B to C. All right. All right. Let's do a couple more. All right, so now we have this graph, okay? It says on what intervals is F decreasing? So what does the word F decreasing mean? It's going down, all right? Kefa, where is this going down? -1 to 2, and that's it. Do we have anything more? No, not at all. All right, and then on what intervals is F negative and increasing. So what does it mean to be f being negative? That means where? Where's my function if f is negative? Below my x-axis. And what does it mean for f to be increasing? It's going up. And so, where is f negative and going up? Negative 5 to negative 3. All right, right there. All right. I'd like you to try numbers 11 and 12 right now. Okay, so it says point A located at negative 1, 0 is the only point in which G changes concavity. All right, so it's telling me where my point is when it changes concavity. It does have a special name, but I'm not going to tell you the name for it right now. Sure, I'll call it. It's a point of inflection. We don't need to know it yet. All right, so on what interval is G decreasing? Well, what does that mean? G is going down, and G is concave up. Okay, so where is G going down and concave up? Hung? Negative 1 to 1. Exactly. It's going right there. All right, beautiful. All right, and then it says, on what intervals is the rate of change of G is positive and decreasing? So what does the rate of change of G being positive mean? It means it's going up. Okay, and then it says the rate of change is decreasing, so it's going up and what? It's concave down. And so where is this function going up, yet it's concave down still? Negative 5 to negative 3. All right, so it's negative 5 to negative 3. All right, quick recap. So if f is positive, that means it's where? Above the x-axis. If f is increasing, what does that mean? It's going up. What if it says the rate of change is increasing? Concave up. What if it says the rate of change is positive? It's going up. All right? And if you want to substitute the negatives in and decreasing, they mean the opposite. All right? And that's pretty much it.